Dear friends, this is Srinivasan, who is having more than 40 years experience in this construction industry, trying to present you a small presentation of how to calculate shuttering area for various members, along with how to find out the quantity of cement, sand, water in plaster. It's a civil conclave presentation. How to calculate shuttering area? Shuttering is an arrangement done for vertical surfaces to support the wet concrete till it attains the desired strength. Shuttering is part of a formwork. Follow below to know how to calculate the shuttering area. This is the image of how the column shuttering has been carried out. Learn about shuttering. Calculating the shuttering area. The shuttering is calculated in terms of square meter. In the rate analysis of shuttering, in order to calculate the area of shuttering, you must know how to calculate the peripheral length of any shape. Peripheral length, that is a perimeter. Perimeter is the distance around two-dimensional shapes. For example, square has four sides. Determine one side length is S. So the peripheral S is equal to S plus S plus plus S is equal to 4S. Important formulae for calculating shuttering area. Perimeter of square is equal to 4S. S is equal to length of the side. Perimeter of rectangle is equal to 2 into length into B. L is equal to length and B is equal to breadth. Consider the perimeter of a circle is 2 pi r. R is equal to radius of the circle. Area of a rectangle, length and breadth. Area of a square, side into side. Remember, each member in structure, either it may be a slab, beam, column. It has 6 sides. Shuttering area can be calculated by using two methods. One is by below mentioned formula, and other method is by calculating the individual areas of faces. To keep it clear, we try to analyze both the methods. Formula of shuttering area. Shuttering area is equal to peripheral length into depth. Calculation of shuttering area of a column. Consider a column is shown as per the below figure. To calculate the shuttering area, simply follow the following steps. See here. This is a column width is equal to 0.8 meter, 8 meter, the height is 4 meter. It's at 1, 2, 3 and 4 sides. For column shuttering is done on 4 sides. For column as a top face is left for pouring concreting and bottom face is fixed at a ground level. Hence no shuttering is needed for top and bottom faces. Shuttering has been done. The side of the column is in a rectangle shape with a side length L and breadth is a B. Peripheral length of a rectangle is equal to L plus B plus L plus B is equal to 2L plus 2B. Shuttering area, peripheral length into depth. Peripheral length 2 into 0.8 plus 2 into 0.6, that is equal to 1.6 plus 1.2 is equal to 2.8 square meter. Total area of shuttering of a column 2.8 into 4 is equal to 11.2 square meter. In case the shape of the column is circular, then the below mentioned formula is used for calculating the shuttering area. Shuttering area of a circular column is equal to 2 pi r into depth. Calculation of shuttering area of a beam. For calculation purpose, I am considering the beam as shown in the figure. This is a phase 1, phase 1, phase 2, phase 3, phase 4, phase 5. Okay. The length is 6 meter, the width is 0.600 and height is 0.8 meter. For beam shuttering is done in 5 sides. For beam, top face is left to fill the concreting, hence no concrete shuttering has been done on the top face. For beam, shuttering in done in 5 sides, and the other side, top side, is left to open for filling the concreting. Shuttering area can also be calculated by finding out the individual area of each faces as follows. Face 1, area of rectangle, length into breadth, 0.8 into 0.4, 3.2. Face 2, area of rectangle, length into breadth into is equal to 0.6 into 0.4, 2.4. Face 3, area of rectangle, length into breadth, 0.8 into 0.4 is equal to 3.2. Face 4, area of rectangle, that is length into breadth, is equal to 0.8 into 0.6 is equal to 0.48. Face 5, area of rectangle is equal to length into breadth is equal to 0.8 into 0.6 is equal to 4.8. Total area of shuttering is equal to 3.2 plus 2.4 plus 3.2 plus 0.48 plus 48. That is 2.765 square meter. 9.76 square meter. Calculation area of slab. Slab is rest on the beam. There is no need of providing shuttering to the slab on 4 sides. Same as beam and column, the top slab is left open for fill the concreting. Hence, shuttering only provided at the bottom of the slab. The below mentioned value are considered finding the shuttering of a slab. See the images. This is the length, this is the width. Okay. In slab, shuttering is laid only on bottom area. Slab rests on beam. Hence, all other sides are covered with the beam shuttering. Hence, no shuttering is required in the top. Shuttering area of slab. Bottom area of slab is equal to length into breadth. That the bottom area is equal to 5 into 4 is equal to 20 square meter. Now, let us discuss about how to calculate the quantity of cement, sand, water required for plastering. Plastering refers protecting a wall or a ceiling by laying a plaster. Plastering is done to remove surface imperfections caused by brickwork and to keep the surface smooth for plastering. There are many different types of plastering materials. Out of them, cement plaster is extensively used. Some of the other types of plastering materials include lime plaster, clay plaster, graniting plaster, etc. Calculating the quantities of cement, sand required for a plastering. General points to be remembered in plastering work. The ratio mentioned in plastering are volumetric ratios of cement and sand. That is, example 1:5. If it means 1 part of cement and 5 parts of a sand in the mortar. The overall thickness of the plastering should be minimum 20 mm including 2 coats. Cement has a dry density volume of 1440 kg per m cube. Each bag of cement weighs 50 kg, that is 110 lbs. The volume of each cement bag is equal to 50 kg divided by 1440 is equal to 0.0348 cubic meter. The dry density of the sand is 1600 kg per m cube. The plastering is done in 2 layers. The first coat of plastering is laid with a thickness of minimum 12 mm, and this coat is called as a rough coat or a primary coat. The second coat is laid with a thickness of 8 mm, and this is called a finish coat or a secondary coat in the plastering. Total plastering is equal to first coat plus second coat. Different ratio of cement mortar used for plastering are tabulated below. 1:6 and 1:5. This is generally used for a brickwork. 1:4 used in ceiling and external walls. 1:3 as it is a rich mortar mix and is used where externals are prone for a severe climatic conditions. It is also used for a repair work. Steps involved in calculation of the plastering quantities. Find the total area of the wall to be plastered. Consider the ratio and thickness of the plastering. Calculate the total volume of the plastering. Find out the volume of cement and sand individually for both the coats. Calculate the total volume of cement and sand required for a plastering. Now coming to the calculation part. We are considering the below values for calculation purposes. Wall size is 10 meter by 10 meter. Ratio of first coat plastering, that is 1:5 with a thickness of 12 mm. The ratio of secondary coat is plastering is 1:3 with a thickness of 8 mm. Calculate the area of the square area, that is 100 square meter. Find the volume of the plastering. Volume of first coat is equal to area of plastering and thickness of the plastering. That is 100 m square into 12 mm. When we convert it into meter, it will give you as a 1.2 cubic meter. Hence, volume of first coat plastering is 1.2 cubic meter. The volume of second coat is equal to area of plastering into thickness of the plastering. That is 100 m square into 8 mm. When you convert it into meters, it will give you a 0.8 cubic meter. So therefore, volume of second coat of plastering is 0.8 cubic meter. Find the volume of plastering. Volume of first coat, that is 1.2 cubic meter. Hence, volume of first coat plastering is 1.2 cubic meter. The total volume of second coat is equal to 0.8 cubic meter. Quantity of sand required for a first coat. Total volume of first coat plastering into number of parts of cement divided by total parts. That is 0.8 into 5/6 is equal to 1 cubic meter. Similarly, for a second coat. Second coat ratio is equal to 1:3. Total parts 1 plus 3 is equal to 4. Quantity of cement required for a second coat. Total volume of second coat of plastering into number of parts of cement divided by total parts. That is 0.8 into 1/4 is equal to 0.2 meter. Quantity of second sand required for a second coat. Total volume of second coat plastering into number of parts of cement. That is 0.8 into 3/4 is equal to 0.6 cubic meter. Finding the quantity of water required for a plastering. Amount of water to be added to the mix depend upon the moisture content present at cement and sand in atmosphere. Quantity of water is equal to 20% of the total dry material. 20% of 574 plus 2 plus 560 is equal to 627 liters. Final result. As mentioned above, volume of 1 bag cement is equal to 0.0348 cubic meter. For 0.43 cubic meter, we required 0.4 into 50 divided by 0.0348 is equal to 574 kgs. That is 11.4 kgs bags. For second coat, sand is required. Similarly, for sand, 1 cubic meter is equal to 1600 kgs. 1.6 cubic meter is equal to 1.6 divided by 1600 is equal to 2506 kg is equal to 2.5 tons. Quantity of water required is 627 liters. How many bags of cement required for 1 square meter of a plastering? In the above mentioned values are considered for this. From above 100 square meter is equal to 574 kgs of a cement. 1 m square meter is equal to 574 by divided by 100 is equal to 5.7 kgs of a cement. Summary. Quantity of cement, sand, water required for plastering of 100 m square wall. Its first and second coat of cement mortar ratio 1.5 and 1.3. Then the quantity of cement required is 574 kg. Sand required is 2506 kg. Quantity of water is required 607 liter. Thank you for watching this presentation. Kindly subscribe, like and share, which will motivate me for a further good presentation. In case of any queries, do not hesitate to write to me. The response shall be at the earliest. Contact me at civilconclave@gmail.com or at my Telegram group, Ask Srini Telegram group. The link is as follows. Please kindly subscribe, like and share, which will motivate me for giving you further good presentation like a mixed designs, steel tabulation, steel calculation, etc. etc. Thank you for watching this presentation. Kindly subscribe, please. Thank you once again.